Hey, we're going to do a quick Zoom review here. This is intended for a particular student who was unable to join us during the Zoom today, which is probably my fault because I probably gave him the wrong code. But there's no harm in other people that might like to go back and review what we talked about. It wasn't a particularly heavy algebraically heavy or mathematically content heavy Zoom. There was one critical issue though, and if you weren't there, you have to know this. We brought up this for the first time. Now, maybe you've seen it before, maybe you haven't. It's a mathematical constant. And mathematical constants are things like pi, square root of 2, the imaginary unit, phi, e. Why are they called that? Some people call this number, they use the word a transcendental number. The reason that term is used is because we think as mathematicians, and I think it works, you know, for most people to look at it this way. If no human had ever been born on the face of the earth, pi would still exist. Every circle divided by its diameter yields pi. So it has nothing to do with us. We didn't write it or create it or design it or plan it or engineer it or anything like that. Pi can't be considered something that we have invented as humans. On the other hand, it must be considered something that we discovered. We found a technology by looking at patterns and by investigating things in the natural world. And pi came to us. We've been using it ever since to great benefit. E is another one of these numbers. Now, it's not something that we designed and decided to create and make. It's something that is observable. It's something that's observable in the natural world. Just the same way as like a blue whale or a virus particle or a mosquito. Those things exist. E exists. Okay? To define it is a little bit harder than it is to define pi. Pi is particularly easy to define, just circumference divided by diameter. But let me start by saying that this value is closely linked to the way the natural world makes growth occur for things that are living or non-living. The growth in nature follows with E. I'm going to get to that. Death in nature follows with E. Decay, decrease, loss, all have this kind of weird, mysterious connection to E. And that's what makes it cool. And that's what makes it the last thing that I wanted to capstone onto this block of exponential growth and decay by looking at nature's version of that. So we don't have to deal in f of x's and blackboards and algebra and math notations and symbols. All we have to really do is look and we'll find it. Examples. Where do you see it? Okay. Here is my bag of jewels. As you can see, I'm quite the wealthy sultan. I've amassed a tidy, handsome bag of rubies here, and I'm going to deposit them in my local bank, and the bank is quite generous. They're going to give me 100% per year interest. Sounds really good, actually, doesn't it? Definitely not true. Okay, so with this 100% a year interest, wow, this is fantastic. Fantastic. After a year, I'm going to have 2 of these bags, right? That's what 100% interest does. Instead of having 1, I'm going to have 2. After 1 year, 100% interest, now I've got 2 bags of rubies. What if I called up my banker and I said, yo, this is Sultan on the line. Yep. Look, you know that 100% interest thing? Just let me make a little adjustment to that. It fits my financial situation a little bit better. I'm building a new palace. Would you mind, instead of 100% once a year, would you be cool if we just do that 50% after 6 months, and then you pay me that 50% interest after 6 months, and then 6 months later you pay me the other 50%, so we still got 100% interest for the year, right? You don't mind, right? Okay, good, cool, thanks, bye. Hang up the phone. No, that was a smart move by the Sultan. In this story, that I'm the Sultan, so that was a smart move by myself. I did that for a reason. I kind of tried to convince the banker that it was the same thing, to take 100% interest over 1 year and chop it up and do 50-50. 56 months, 56 months. It's not, though. It's not even close. It's much, much better for me if I'll take 50% interest after 6 months. Now I've got a bag and a half. And then 6 months later, I'm going to take another 50% interest. Bag and a half. With another 50% interest, well, a bag and a half. And now I'm going to take 50% interest again for the remaining 6 months. That's going to give me 2.25 bags. It's going to give me 2.25 bags of rupees at the end of the year, just because of that phone call where I changed it up from being 100% once to 50% twice. Okay, now let's follow. This is the mathematical process. This is, like in science, you have the scientific method. This is the mathematical process you follow with patterns, okay? So if that's happening when I split it up into 2, what happens if I split it up into 12? What if I called the guy back and said, hey, yeah, I know, it's probably annoying, it's me again, Sultan, Nate, and I'm just going to go ahead and switch that up and do this on a monthly basis. I want that interest paid on a monthly basis. 100% interest a year, yeah, you don't have to change that. But I'm going to go ahead and collect every month. Good? Good. Okay. I just benefited again significantly. So I'm going to take now my interest every month. And I know I told you this wasn't an algebra heavy kind of concept, but I will show you the function because we have been looking at them. I started with 1 bag of rubies, and I'm going to take now 1 plus something because I'm growing, I'm increasing. This is exponential growth. 1 plus 1/12 because I'm going to have every month now. Every month now. So that has to now be raised to the 12th power. This function, go ahead and do it. By do it, I mean evaluate it. Okay, GEMDAS, always follow your GEMDAS. Sometimes kids groan, like, God, we know, but you'd be surprised. Follow your GEMDAS. G stands for your grouping symbols. That takes precedent even over the exponent. And you've heard me harping over the last few weeks, you have to do the base to the exponent before you multiply by the coefficient. Base to the exponent first, base to the exponent first, then you can multiply by the coefficient. Yes, but even before that, there's a G. So the G is a grouping symbol. So grouping symbols get the number one priority of our attention. So 1 plus 1/12 happens first. 1 plus 1/12, raise it to the 12th power. Do that on your calculator. I can't do that in my head. That's what calculators are for. Not 24 divided by 4, but 1 plus 1/12 to the 12th. Do that on your calculator, okay? And obviously that's times 1, so this 1 doesn't matter. Multiplicative identity, right? So 1 is irrelevant. So what you get is, now, being the wily businessman that I am, I've got 2.69 bags of joules. All in the same year where the banker thought they were just going to give me one more bag. That's cool. Remember, this is every month. I can tell you right now, if you did it every day, you'd get 2.71. If you did it every hour, you'd get 2.7183. If you did it every minute, every second, if you did this interest compounding process as often as possible, you will benefit more and more and more and more. The more frequently you can take that interest, the better your financial outcome will be. Okay, so that 100% interest, if you can chop it up into its tiniest possible increments, you're moving toward, you're following a path moving toward infinity, infinitely small pieces of time, such that another way to say a series of infinitely small pieces of time, another way to say that is continuously, constantly. So if I'm constantly, continuously making my interest, collecting my interest at a continuous rate, how many bags of joules will I get at the end of the year? I will get exactly, not close to, but exactly E bags of joules. Cool. I didn't make that up. No human decided on that formula. That's just nature. That's just true. The best possible outcome for 100% interest with an investment is to collect on that interest, continuously compounding for an entire yearly period of time on that 100% interest, and the best you can do. The best you can do is 2.71828819, and this is an irrational number that has decimals that go out forever and never ever end and never make a pattern. That's E. There's a lot of other places you can find E and see E and derive E, and I show you a bunch of them on my Explain Everything videos, which are posted on Google Classroom. So this was basically exactly the Zoom that you missed today, and if you already saw the Zoom, it might not do you any harm to watch this video again. Either way, I'm happy that I could help, and I am always here for further clarification if you need it, okay? All right.